Hello, lovely, beautiful people. I hope you're having a great day. I want to talk today about the double slit experiment, and I was very in quantum mechanics and light, and I was fascinated about this these questions that you get from this, and I try to understand why this effect happens. So let me quickly tell you what a double slit experiment is when you take a light and you force it through like a slit, like a small, like you take like a piece of paper and you make carve out a small piece where it can go through, then it will go through, and of course what would you see on the other side? You would expect to see a line on the wall where the light goes through, right? But the thing is, what happened when they did that with like two next to each other is that instead of seeing two lines, they saw like a a lot of lines. Like you see here, you see like not one line or two lines, you see like a row of lines. Let me watch the video a bit more. So, and that's strange. Why is light splitting up into multiple lines and making multiple rows while you're just dividing it once? And that is a really fundamental question about light. Like, what is light and why does it do that? So, so you get into the idea of that light is, well, we have this idea that light is like a beam. It goes from one point to another. It's like a particle that goes in a straight line. But then there are other people that think it's like a wave, and these waves, they interfere with each other, and that's why you get this interference pattern. Now, I've been thinking a lot about that, and then you have the problem is that when they did like one small photon, like one light particle as they call it, when they did this one light particle, this one photon, well, what is a photon? A photon is what they call it photons because I think that Einstein was that who came up with this, or it's like the light is really like, you cannot, like normally you would have a slider, like if you go like, if you have you go like 1 2 3 4, you can have, but you have like 0.1 or 0.1 or 0.1, you can keep dividing something. Well, with light you cannot endlessly divide light. At some point when you go there is a minimum amount of light that needs to be put out before you get light. So there is not so those are like that's the quantum, those are the quanta. That's the minimum amount of energy that needs to be there to have a photon. So when they send out this photon, this one volume of light, they would expect to get like a small like blip on the other side of the screen if it goes through this slit, right? And if they do a lot of them, they would see a line, because the light, it's really hard to focus a light at one point. So when they emit a light photon, it will go somewhere on that slit. It will go somewhere up or down. So you will get lines of light on the other side. If you would do like a photosensitive wall or something, you would get a like. You would see like a line appear there from all the photons going through that slit. Now, when they did two of them, then they got this interference pattern. But now the funny thing happened. Is even with one photon going through one of the two slits that were next to each other, they still got the interference pattern. And that was like, that's mind-blowing for physicists, because that means that something had to go through the other slit that they didn't send through, that they didn't know that existed. They don't know what it is, what is going through that other slit, but it seems like there is something going through that other so just that is there, and they cannot explain what it is. So there must be something there, and and that's very interesting. So you get and that's when I start to think that, well, light isn't this idea of that it's a particle. We tend to think of particles. We live in a brick and mortar world. When we look around us, we see we learn what a molecule is by thinking about like a piece of iron, right? Now you have lots of it's like a big piece, and then you would think like, well, a molecule. We think about particles and molecules like very tiny pieces of matter, like a sense of like pieces of sand, but then even smaller. But we still think of it as matter because all we know in this world is matter, except for, of course, light, which is a bit different. And there's lots of other things also than matter. But what we see mostly in our world is matter, something that we can physically touch, that we can shine light on, and that reflects light back, that we can see. So when we think of a particle, we think of one of those solid things. But basically, we're talking about this universe. This is on the quantum level, on this very tiny level. We're talking actually about forces. All we really know is that there are forces. That's the only thing that we really know. And my vision of this world is like, of this universe, is that all we really know is that there are forces, and those forces work on each other. They have effect. We have electrons that go around atoms, and atoms that have effect on each other, and and that is what forms our world. But they're really, all we know that there are forces at work, and those forces have an effect on each other, and they either attract each other, or they put each other in, they bounce off each other, and that's all we know. So but with a photon it's different, because we can it's kind of like, how do we really know what a photon is and how it works? So but the thing is, because with the double slit experiment, something goes through the other slit while there's only one photon going through like the left slit, and something must have gone through the right one. So I think that there is more than just that the photon must be like bigger, right? So that's the only thing, like something, a part of that photon that you just put through the left one, a part of that is gone through the right, or something has gone through. So that's what I was thinking about. There is more than that we can see, or more that we are aware of, because what is going through the other one. So, and that's my how I think of it. So I was curious about what is really light. Is it what is really happening there? And mostly, so I asked ChatGPT to oh wait, I'm doing it alt tab. I should be doing this. Yeah. So if I look, I did like with ChatGPT, I asked some questions. Now, of course, you just heard, I do know a bit of quantum mechanics, but I just want to know what was their, what would they say, and can I use them to fill in the gaps, some of the things that I don't know. So I just started with a simple question: what is light? Because you have to start a conversation that you can build on, and then you can reference back to with ChatGPT. So they give me information, and then I can build on that. So I would just keep asking questions. So it gives some of the basic information on what light is. Then I say, well, where does light go if it's no longer visible? To be honest, I have to be completely honest, I don't think I knew. I didn't know that. That was the question that I had, and I thought, well, wow, this is something great to ask for ChatGPT, because even though I was thinking about light and all these things, that's not something that I knew. So, but I did know the other things I already told you. So, and then absorbed by an object or scattered in another direction. Now this, of course, I knew, but that and I know that it was absorbed by objects. You know that a black object absorbs more than like a white object, because the light, that's why you see colors, because certain certain parts of the light. The light is not just white. Light has all these colors in it, and certain object like black absorbs all the colors of the light. So that's why, and it gets most that when you on a summer day, when you have like a black t-shirt or something, you'll get much more hot than if you have a white t-shirt. And white reflects most of the all of the colors, most of the light. It doesn't really hold one color. So, and then with color objects, anyway, so that's how it works. But so I knew it was absorbed and reflected. That's no different. So now here I want to, of course I want to know on the quantum level. So what happens on the quantum level, because that was really interesting. So here, when a light particle, a photon, with appropriate energy level approaches an atom, it can be absorbed by an electron in the atom's outermost energy level, or valence shell. Now I've learned about valence shells. So you have different like, let's say that there are like, yeah, a shell. It's like you have an atom, and then at some distance from that there are electrons moving. But then at another distance there could also be electrons, and then at another distance there could also be electrons moving around the atom. And these are different yes, they are, some are closer, some are further away, but they're also all at like the same kind of like distance. So it jumps from one distance to the next distance to the next distance. So, and it says that it can be absorbed by an electron. So the electron absorbs light when it approaches it approaches the atom. So the atom's outermost the valence shell, the energy of the photon is transferred to the electron. So the energy is transferred to the electron, which increases the electron's energy level. So, and raises to a higher energy or excited state. So these electrons, they become more energetic when they absorb this light. Now here it just gives you the basic blah blah blah. Let's look at the next one. Is there a what did I want to, okay, so I have to some things are obvious for me, they might not be obvious for you. So so what is the problem with, there's a big problem here, because basically it says it can be absorbed by an electron, but absorbing something like if I absorb something, it becomes part of me, right? So it doesn't disappear, it doesn't gets destroyed, or it doesn't get like evaporated or ceases to exist. It's still there. So absorption as we know it, normally it doesn't, maybe it can change, something can change from one state to another and take a different form while it's being absorbed. Now, so we're looking at the words that they're using here. So, and then of course it talks all the valence shells, and this is important because when the electron gets this energy from this light, it doesn't want to stay at the same valence shell. It wants to go one up, or it gets this extra energy and has more energy, and it can do more now than it did before, you know. So there's something added to it. It changes, the electron exchange is no longer the same. So, and it also says the energy of the photon is transferred to the electron. But the thing is, we can talk about energy all day. Like if I put on like energy at this level, at the quantum level, talking about energy is really not saying much, because the energy of the photon, I didn't even know, like the energy of the photon. What is the energy of the photon, right? That is, well, it's going at a speed of almost 300,000 kilometers per hour. That's really fast. Now we know that light has energy because when you put light on the surface, like on a black surface or even white surface, it doesn't matter. If you put light on the surface, it gets warm. You get warm when you walk around in the sun. So we know there's energy there, but the thing is, and then it says that energy is transferred to the electron. But what does that really mean? What's the process of this energy going? How does this work? How can electron receive energy? So I say, well, we have a photon. The photon kind of like it's absorbed. It's no longer doing anything, and now the electron has more energy. It moves around like first energy, an electron goes like this. It's like a bit sluggish, and then then it's hit by light, and then it's hit by more light, hit by more light, and before you know it gets so much energy, then boom, So high energy excited state. So it's like it's excited, so it's moving more. We have always, so that's interesting. But really, what's going on there? So is there a limit? Of course, I'm asking the obvious questions that I already know the answer to, but I need to go somewhere with this ChatGPT. See what does science think about this? I know what I think about it. I know what I've learned about it. But what's the basic? What if I ask a professor? This should be like, what if I go to a professor, which I sadly cannot do. Although one of my latest teachers, he wrote a book about quantum mechanics, so maybe I would love to talk with him about this stuff one day. Maybe I'll give him a call. Maybe he wants to have coffee with me. But anyway, instead of talking to him, I asked ChatGPT, and so what happens when you have now, of course. I did not ask a question, where does light come from? Well, we know that light comes from a light bulb. When electrons go in, electricity goes in there. And there are many other ways also when you burn something, and the sun, of course. There's so many ways where light can come from. But this is where we're going now. So the amount of light that an electron can absorb is determined by its energy level. When an electron absorbs, a photon of light absorbs a specific amount of energy that's equal to the energy difference between its current energy level and the higher energy level, whatever. So it goes up, same as the other story. If an electron absorbs more energy than it can handle, it will become unstable and may undergo transitions to even higher energy levels. So this is the valence levels. Eventually, the electron will release some of its excess energy as a photon of light, returning to a lower energy level in the process. So it's going up levels. It's like the distance between the atom and the electrons is like is getting further away from the atom, the electron, in the valence shell, because it has more. It's moving around more, and then at some point it receives that much energy that now it actually shoots out a photon, and a photon goes out of there like I said, almost 300,000 kilometers an hour, and that's fast. Now, if you look at Einstein says that it's a constant of light, 300,000 kilometers per hour, almost. So it's a constant of light, and he says that if you go at that speed. And he says also that it's because of at that speed time stops. So he says that as you get closer to that speed of light, time slows down, and then at the speed of light, time stops. So that's the reason why you cannot go faster than 300,000 kilometers per hour, because at that speed, time has just stopped, and you're not able to go any faster. Now, I have an idea of why maybe might be another reason for that speed. Because if you look at a car, where does a car gets its speed from? Well, it gets the speed from the engine, right? And where does the engine get the speed from? It gets from burning gasoline, from getting energy from an energy source, and then that's transmissioned into the wheels, where they will grip the road and will move the car forward. So having speed, you don't just get speed by like flicking your finger or saying something, oh, now we have speed. So speed comes from somewhere. Either you already have it, or you are getting it from energy transference. You will get speed. So, okay, let's go on to the next because I'm telling the whole story without. So photons can be added or removed from electrons. Electrons can at least partially made of photons. So here I'm talking about what he says. He's talking about photons like they are. Yeah, he talk about adding and removing electrons. So that photons are added to it and going from it. So I'm saying, well, are they at least partially made up of photons then? Because it seems that, like, let's say I walk into a room and I close the door behind me. Now, you look at the room and you meet the temperature, and the temperature goes up because I'm in the room, of course. So the temperature goes up, but you cannot see me. You do not know if I'm still alive or in there or whatever. What happens to me? All you know is that the temperature went up in that room, and there's more energy in the room. Then the door opens and I come out running because it got so hot in the room. I run out and then I'm there again. So when I was in the room, did I cease to exist? Well, very unlikely that I was not in the room. You could not see me when I was in the room. You could only see me going in the room and closing the door, and you can see me going out of the room running. And you could see that there was more energy in the room while I was in the room. So all logic dictates that I was in the room all the time and that I came out. But here, so that's what I'm saying. Like, well, if light is part when the light is added to the electron, doesn't it just become part of the electron? Because the electron changes state, it becomes more energetic. So it is changed. It's not the same electron anymore. It has more energy. It makes sense that the photon is added. Let's say that there is some kind of, like, we cannot see light, but we know that in the world, in the atom world, we have an atom. And the atom is made out of protons and neutrons. They are circled by electrons. If we look at the sun, it is circled by the earth. We can see there is this thing in our universe where energies are either attracted by each other and are either get close to each other and stay close to each other because of these attractions. And then when energy is added to these things, then the force of attraction that's holding them together, it might be like if you would like if an asteroid would hit our moon, if it had enough energy, could be moved away from the Earth. Because it receives so much energy now, because the moon is going around the planet Earth because of the gravity, and the gravity is holding it in place. The gravity between the two bodies are holding them together. But if the moon is hit hard enough by something, now it is moved. It can the energy that the direction of the energy that's now on the moon is so different than it's greater than what is holding him to the Earth. It could get blasted away from Earth. That could happen. It probably would destroy completely the whole moon and stuff, and lots of the planet Earth too. But I'm just trying to explain that these forces that are holding those things together is the same thing. Like if you just drop an orange on the floor, that's gravity, right? But if somebody hits the orange while it's traveling at the floor, it's not going to hit the floor straight away. It's going to travel in the direction it was hit, like a ping pong ball or like a tennis ball. If you hit it before it hits the floor, it will go over the net, right? Or so. So you see that if you look at the world in forces, you can see that there's always forces working each other. So now and if I look at like I said, like with the double slit experiment, it seems to be more about photons and light than we assumed there to be. like the simplest way to look at a photon is just one particle that moves in a straight line. But this double slit experiment proves that there is more to it. So, and I think you also have quantum entanglement, which kind of, it's hard to, it's been a while, but it's like where like there are two particles that are entangled with each other. And I've looked, I think, of some Stanford courses, and they had these machines where they would put a particle in, and then a particle, and then it would go in it, and they would look at it. It would be either like be A or B, and then they would like group it. But if you put it to another machine in a certain way, either it would go out like A and B again. But if they would do it differently, then it would be it wouldn't be A or B. It would be something different. So it's like they're like when you and I know if you know like Schrodinger's cat. It's like when you look at, like, you have a cat, and the cat is in a box, and if the cat's in a box, you know there's poison in the box. No, it's sad, sorry, but there's poison in the box, and you don't know if the cat is poisoned or not, if it's dead or not. If it might not be poisoned, then it's still alive, but if it's poisoned, it's dead, and you don't know until you open a box. Then you know if it's dead or alive. But at the stage where the box is closed, you're really unaware of the situation. So Schrodinger's cat, it says, well, at this point the cat is both dead and alive. I know it doesn't make sense, but that's why, like, and when you look at these particles, they are like, what did I just say? Quantum entangled. So it doesn't matter how far in the universe these two particles are, they're always in the same state. So if you look at the particles, if you look at particle A, and and it's in state X, then if you would look at particle B, it would also be in state X. If you would look at particle A, it would be in state I. It would, and then X, or then B would also be in state I. You don't even need to look at the other state. You know that they're in the same state because they're quantum entangled. They have the same value, but you don't know it until you look at it. And that's so much stuff. Anyway, it's quantum mechanics, and I know it's really weird, but so I was asking. I don't even know where I was going but I had to explain all this stuff. But so yeah, it's talking about absorption and stuff, but that doesn't absorption can mean anything, you know. So what I'm thinking that is things don't cease to exist. Well, let's go to the next slide, because what happens if the photon particle is energy absorbed by an electron, and where do photon particles come from when they are released as light from electrons? So here I'm asking an explanation for these things, which I already know that I'm not going to get, but because I already have my own idea on what's happening, but I know that they're not going to tell me that. When a proton is absorbed by an electron, the energy of the photon is transferred to the electron. So it's saying that somehow energy is transferred from the photon to the electron. But what happens to the photon then, if it no longer has the energy, right? Raising the electron's energy level. So now the photon suddenly has more energy. It's moving around more because it had this photon hit it or something. Okay, sorry. The photon itself ceases to exist. Here, this is what I'm talking about. I'm going to get some water. The photon itself ceases to exist. Well, that's interesting. Because if that is true, it means that when you have energy, you can create energy, photons, you can create them from nothing, like your God or something. And then you can also make them non-existent, like your God again. You can just make them like get away, like pff, boom, you're gone. You're no longer existing. So the photon itself ceases to exist as it has been completely absorbed by the electron. Well, the thing is that where does light come from? It also comes from electrons. So, like I said, with going into a door and going out of the door, I don't think that when I go into a room, if I go into the kitchen and I close the door, I don't cease to exist. I'm just in the kitchen. You know, so I think that actually the photon becomes part of the electron. That's why it has more energy, because the 300,000 kilometers an hour that it's traveling at, it now somehow is doing that around some kind of like, as I'm saying, like, I don't know what a photon really is. I don't know. We really know what photons really are? That's the question. That's what Einstein was researching, trying to find out what light is. That's what Newton wanted to know. What is light? All these things, it shows me that photon is not just one, or photon is just well, an electron isn't just one like thing, you know. It could, because light can go into it and light comes out of it, and you can tell me that it ceases to exist, the photon, and then it gets created out of nothing here. Similar, when an electron releases, so it's releasing a photon. So if you're releasing something, aren't you holding on to it before that? You must have been holding on to it, right? Like if you captured it and then now you're releasing it. Yeah, that's why it's so interesting the way they talk, that it tells you something. So you cannot release something, but it is releasing some of its energy as light. It's releasing energy as light. It's releasing energy as light. Wow. Releasing energy as light. Wow. It sounds so cool, right? Well, this is what, obviously that is what it's doing, but energy as light. So it means that the energy, how did the energy become light, right? So you have energy and now it's light. Did somebody do something to it? Like, did a magician turn energy into light? Did God do it? What happened? Well, maybe the energy already was light. You know what I mean? Maybe the light never. I mean, you got photons coming in and out of electrons. Maybe those photons just stay with the electron. And like, I think that the electron, when it hits, I think the photon, when it hits the electron, it loses some of its speed, the 300,000 kilometers an hour speed, almost. And it gets stuck to the electron, because the electron has like some kind of force working on those. It becomes part of the electron. They stick together, and maybe the electron is just a bunch of light, or maybe it has a core that attracts light and holds and holds. I know it's hard to talk about mass, because they say that photons don't have mass, and I don't know if electrons do have mass or not. I mean, electron, we look at the proton and neutron. I remember that the proton and neutron, they have the mass, but for the electron to stay around these protons and neutrons and move around it, they must have an attraction too. So the electrons must have some sort of mass themselves too. Might be very tiny, but they must. You cannot, like, there's a force between the electron and the proton and neutrons. They all have forces. That's why they stick together. Atoms would fall apart if there was not some kind of like force working in between them. So I think there is a force also with the electron and the light. When the light comes very close to these electrons, they stick together. And they lose, so they become together, and maybe they do lose some of their speed. Their speed becomes part of the so they some of their, and then when they have enough, so when these photons have enough speed again, 300,000, then their speed, their energy, the speed is to the strength the speed is too high to stick with the electron. So what happens, the electron can no longer hold the light because now it got extra speed from bumping into other light light particles that and then because it has too much speed, the attraction force of the electron is not strong enough, and it happens at its speed that is nearly 300,000 kilometers an hour. That is c, the speed of light. At this, when the light particle or when the photon has this reaches this speed, it no longer, so it shoots away from the electron, and it goes on its way again until it reaches another electron, maybe in a fraction of a second, maybe in a billion years, but and that's how it works. I know, call me crazy, but anyway, that could be an explanation, and I think that that makes a lot of sense to me. Now, I'm not trained in quantum mechanics. I'm not trained in physics, so there might be some things that I don't know about that makes it obvious why this is not possible. But I'm not yet aware of it, and I asked this ChatGPT, which should know all these things about. It is almost like asking a professor some basic questions. So yeah. So it carries away the excess energy that the electron alone no longer leads. Well, that makes no sense. Carries away the excess energy that the electron no longer needs. Oh, I don't need it. Here, you can have it. Here, photon, here, take some of my energy. No, I think that what happens is that the photon, now it reached a certain speed, whereby and it has so much speed it no longer the force of the electron no longer can hold that photon anymore, and now it just moves away from the electron. And it's all and why do I think that? Because it's always the same speed, right? So let's say that every electron in a universe has force x. Yes, this force x can hold photons in its proximity if the photon is below c. Now, if it reaches c, the photon, x is not strong enough to hold a photon with speed c, which is at speed c. So at this speed it goes away from the electron, and that's when we measure it to be at speed c. Then if it at some point in a second or in a billion years reaches another electron, when it hits that electron, maybe it transfers some of that, it loses some of that speed, or it has lost some of the, I don't know, for some reason when it approaches another electron again, now it can get stuck on that. Let's say it bumps into an electron. Let's say the electron has a bunch of photons, yeah, flying around it. Then another light particle, photon, hits the electron, so those photons now receive some speed from being bumped into from this new photon. Now some of those photons might reach speed c, which is strong enough to get released from strength x that the electron has on them. So now those photons get move away from the electron, as long as it's not bumping into any other electrons. It can go again for another billion, several hundred billion years or seconds or whatever. It can just And that's how these energies are being transferred all the time in between electrons and photons. So, but I don't think that photons cease to exist when they hit. No, because I don't think you can go from 0 to 300,000 in like, you cannot just create a particle, you cannot just create a photon and then chuck it away at the speed of 300,000 kilometers per hour. I don't think that is that's also the creation of particles. Okay, now I've talked. Let's just go through this because I'm way ahead of all this. In general, the process of light absorption and emission is a way for electrons to gain and lose energy. Blah blah blah. So, does the photon escape the pole of the electron when it has enough energy, or escape velocity? Now, escape velocity is kind of what happens with like celestial bodies, but I'm trying to get some answer from them. No, the concept of escape velocity does not apply to interaction between photons and electrons, of course not. Escape velocity is a measure of the minimum speed that an object must have in order to escape the gravitational pull from the celestial body. Well, that's true, but that's why I use this term escape velocity, because I think that they said that the electron or the photon was released. So being released or escaping is kind of the same thing. So why does the photon escape the electron? Well, because there is some force. Now maybe there's some force on those photons. The photons are not destroyed or created. There are anyway, that's the question. That's really what's going on with these photons, right? Are they created? Are they what's happening there? But so I'm thinking that they get energy and then boom, they go to speed c. And that if they had that, then they can go above strength x. It does not apply to interaction between photons and electrons, but are governed by the laws of quantum mechanics. Well, that's what I'm asking about. What are the laws of quantum mechanics, right? But they're not going into that. In case of interaction between photons and electrons, the absorption and emission of photons. So we're talking about absorption and emission. Well, yes, we know that there's an emission, but what does that really mean? What's really happening? By electron, it's a way of the electron to gain and lose energy. It's a way. It's a way to gain, lose, or gain, or it's a way of losing. Well, is that all that's I don't think that's not. That's basically just saying, well, hey, we have electrons and they get more energy and they lose energy. Well, what's going on there? When a photon is absorbed by an electron, the energy of the photon is transferred to the. Again, they're just saying that the energy is transferred to the electron. But what happens to the photon? Raising the electron's energy level. Well, I don't. The photon is let's say you know that the Earth is moving around the sun, right? Now I know that is completely different than now let's say now let's say you are in space around in a spacesuit, and you're flying around in space around the planet Earth, and you're moving around it like a satellite, right? When a photon is absorbed by an electron, energy of the photon is transferred to the electron. So, well, actually, that's not a great explanation, because when you as a person are you don't have much effect on the planet Earth. You're very small. So let's talk about the moon. We know that the moon, it changes our ebb and tides, right? It moves the water, it has a big, huge influence on planet Earth. Now let's say that the moon would be would be hit. Let's say the moon was indestructible and it would be hit by lots and lots of meteors or other moons, some energy, and it would start moving rapidly around the planet Earth. And what would happen to planet Earth? Well, because even though gravity of the moon is smaller because it is a smaller planet, it does have an effect on the movement of Earth. So if a lot of energy would be put into the moon, it would influence the movement of the Earth too. Earth could be rotating faster, it could be moving around the sun faster or something. Something could happen to the, if there would be more energy put into the moon and make it move, it would attract the planet Earth towards the moon and make it, and the planet, so the moon would move the planet Earth. Now, so I think that when these, let's say there are photons, that they are like, let's say that, let's just imagine that electron has a core, like an atom has. Like an atom has protons and neutrons. So let's say there's an electron core and there are photons going around it, like electrons going around the atom core, like so these photons are moving around this electron core, and this electron core, now other photons are moving in and hitting those photons start moving faster, and because the photons are moving faster, the electron core is also getting pulled more by the electrons. So the electron as a whole, with all the photons moving around it, is moving more and more and more. And and that's what we see as the energy absorption. The electron having more energy, the electron is moving around more and it's jumping around more because there are more photons pulling on it, and as a whole, and the photons are being pulled towards the electron core. And so the electron is basically a core and photons around it, and the more photons are added to this electron core, the more energetic this electron is moving around because of the pull of all these photons moving around it, circling it, being pulled in all directions. So this, and then it gets more, that's why it has more energy. And then when it has enough photons are hitting this electron, it has so much energy, it will go into this next valence shell, because now it has so much energy that the attraction of the protons and whoa man, I'm getting like tired. So anyway, so it's getting further away from the core of the atom, right? Because it's getting more energy again. So the strength of the core of the atom, it's like it has more energy, so it tries to move away. So now it goes to another valence shell and it can move in that area because it has so much more energy to move around, and it can move further away from the core of the atom. The protons and neutrons. Okay, so yeah. Now what I'm saying is completely nothing that I'm asking about this with the science. They're actually telling me that is not what is going on. So in the case of interaction between photons and electron, absorption and emission photons wave, when a photon absorbed by electron, energy photons transfer to the electron, raising the electron's energy level. Well, I'm explaining that is just because the electron is being pulled, the electron core is being pulled in all the maybe they're just a bunch of photons just stuck together, like because they're just, and they're moving around. I don't know. Maybe there's not even an electron core. Maybe they're just photons that are like sticking together or something. I don't know. When an electron emits a photon, but yeah, it makes sense that there is a core or something. So there could be an electron core. When an electron emits a photon, it's releasing. It's not. I would say it's releasing a photon, but it's releasing some of its excess energy as light. So it's releasing excess energy as light. So, but light is photons, and energy, if you release as energy as light, then it must have been light to begin with, right? You cannot just, are you creating light and photons from nothing? What is there some process where the energy is now? So anyway, again, I'm this already told all this stuff. Is electron releasing a photon not escaping? Is it? So here I'm asking these questions. Of course, it's not going to tell me that I'm wrong. When electron releases the photons, releasing some excess energy as light. The photon is created by the electron. So photons are created by the electron as it returns to a lower energy level, and it carries away the excess energy the electron no longer needs. So here we have electrons that is releasing photons. Well, that makes sense. It's releasing some of its energy as light. So energy as light, then energy is light. So so it's releasing light, is releasing photons. The photon is created by the electron. Well, that doesn't make sense because photons, so then photons cease to exist and start to exist. And that's kind of weird to me. That's things by the electrons it returns to a lower energy level, and it carries away the excess energy. Carrying away excess energy, like, so hey, let's create a mule, and then we put like a gasoline tanks on the mule, and then we send it away. Like creating something out of nothing and then putting energy in it that you don't need, because like we don't need this energy, just give it away on this mule and send it away, because I mean we have too much of it. What's the logic? It makes more sense that the photon was already there and now it got more energy, and because it had more energy, now it escapes from the pull of this electron. It's no longer, because it has speed c again, or it has speed c, or something happens to it that where it can now at this speed, and it goes out of it with the speed c. In general, the process of light emission is an important aspect, blah blah blah. Important note, escape. Note that the photon is not escaping from electron in this process. Well, it's just saying that, you are saying that it's like releasing, but me using the word escaping is not good. So the photon is not escaping from electron in this process. Instead, the photon is being created. Again, it's being created by the electron as it releases excess energy, and it is. So when electrons release excess energy, they create photons. That's an interesting process. Can you tell me something more about it? No. The electron and the photon are separate particles with different properties. Well, maybe not. I mean, probably, like I'm saying, like a photon can travel all the way for billions of years to space from a sun, reaches like my couch with some black cloth on it, and heat it, and then there it can be transferred again to me as heat, this sunlight that traveled billions of years, starlight I should say. Sure, maybe there are kind of particles. That's the thing. Well, they're more or less energy, right? Different properties. I think these things are so hard because once you say things that it's but yeah, I think with different properties they do not have physical connection. Well, that's the thing. They do not have a physical connection. But once a photon reaches an electron, you say that it gets absorbed. So being absorbed is no physical connection. The interaction between the photon and electron is governed by the laws of quantum mechanics. Again, tell me about those laws then. Yes, so electrons can create particles. Yes, electrons can create particles, including photons. In the process of light emission, an electron can release a photon as it returns to a lower energy level, releasing some of its energy as light. This process is known as stimulated emission and is the basis for the operations of lasers. So we're accepting the fact that particles are created. We are creating particles. That's great. In general, I mean, anyway, I think I'm gonna end it here. I'm gonna make a part 2 later, because this is already way too long. I hope you find this interesting. You can read on my Instagram, Stanley the Wekker, the rest. There's also a part 2, and I'm not done this. This is like, there's one more slide to go, and I have another slide here. So think about it, and yeah, you can look at this video here, double slit experiment. It will explain you how very nice visually how the light can how it works and what effects are of light. You have some really, here you can see the effect. She even does it with a hair, also gets the same result. So you see that one hair, you would say that a hair would cut one piece in part, make it one part, but you can see that it's like a dotted line, so it repeats. So this is something really interesting going on here with light. Anyway, yeah, we'll go on to the next one, and I'll go to the other, I'll finish a slide and then we'll go look through the other slides and see what happens. So lots of love and bye bye.